Okay, so we are beginning section 11.2. The page numbers that I'm going to be going through as far as like what it corresponds to in the book here is probably going to be through, let's see, 697 through page 710. I'm not going to do the chi-squared test for independence yet. I will send y'all that one later next week. So we'll just do the first part of 11.2. You can get started on the first part of the homework in class Tuesday. So starting out, how is section 11.2 different than section 11.1? I talked to a few of you about how this basically 11.2 is to 11.1 what chapter 10 was to chapter 9. So we're going to be comparing the distributions of a categorical variable in two or more populations or treatments, rather than just comparing the distribution of a categorical variable in one population to a hypothesized distribution. So instead of like what we did with the goodness of fit, where we said, all right, did the sample fit the population, or what M&M company claimed whenever we did the distribution of colors. In this one, we might compare the distribution of colors for plain M&Ms to peanut M&Ms. So I'm gonna write basically everything I just said. I'm just gonna write a lot, so sorry. Hypothesized or claimed. I wrote hypothesized, but we're talking about claims too. So the example I gave a second ago was color distributions of plain and peanut M&Ms. Or this is also going to be like in the last chapter we looked at one-way tables. We're going to be looking at two-way tables. So maybe one-way. Well, sorry. These are going to be, the way I wrote that was a little bit misleading since I wrote it in the opposite order. But anyways. All right, so let's look at an example here. Market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. What are the two explanations for the differences in the distributions of entree purchases? Well, there are two possibilities, right? Either the music is having an effect on what they choose to order, or music doesn't have an effect on all those differences are just due to chance variation in the random assignment, which is something that we talk about a lot, right? Either we're right, or just due to sampling variation or sampling variability, we got a number that was a little bit off from what we thought it would be. Or a lot off, but. All right, how do you state the hypothesis for a chi-squared test of homogeneity? It's pretty similar to what we did with goodness of fit, except, we're looking at two groups. So our H null could be that there's no difference in the distribution of some categorical variable for several populations or treatments. Right, depending whether it was if it was an experiment, we'd be talking about different treatments. HA, there is a difference in the distributions, blah, blah, blah. You get it. It's the same wording as the null. All right, how do you calculate the expected counts for a test that compares the distribution of a categorical variable in multiple groups or populations? So to get the expected count, let me see, hold on. So to get the expected count, if the null is true, then the proportion in each category should be the same in each population. So the expected count, you're doing it the same way as you did in the goodness of fit, okay? It's just that for the two different populations, you shouldn't have to do it for two groups because your null is that they're the same. So it's just like goodness of fit, what we did in 11.1. Oh, you know what? I take back what I said a second ago. Sometimes if the sample sizes are different, you are going to need to calculate it for everyone. However, the expected proportion would be the same for the same category for the two different groups. Hopefully this will make more sense once we do an example. Same as the goodness of fit test. Just a reminder, just like with goodness of fit, don't round. A little rounding shouldn't make a big difference, but definitely don't round to a full one. The expected count This formula is not on the formula sheet for the exam, AP exam. All right, the conditions are the same again as chi-squared goodness of fit. Which were, well, we always have random, right? We always do 10%. It's our large counts that changes, and it's the same here. So your expected counts are all greater than or equal to 5. Okay. What's the formula for the chi-squared test statistic? We did this in the last section, so it's going to look exactly like what you have in your other notes. Chi-squared is equal to the sum of all of your observed minus expected squared over expected. Okay. How do you calculate the degrees of freedom for a chi-squared test of homogeneity? This actually is a little bit different. So we're going to have, and you can kind of see in the example right below this, hopefully right now, that this is a two-way table, right? There are 2 columns and 7 rows. So we're going to be using two-way tables a lot in this section. And the way you calculate the degrees of freedom is now going to be your number of rows minus 1 times number of columns minus 1. Okay, this is a little bit different. It's still something minus 1, but you actually have to do a little bit more on this one. But again, that's something the calculator will give you, but if you're asked just for degrees of freedom, that's how you calculate them.